today is about rational root theorem. And I want to make sure you understand, first of all, the key words. Root. Roots are kind of a big deal. Do you remember when you'd have problems like this and it was long division? Don't write this down, just listen. And then I would say, does this go into this? Well, this was a factor. The root of this is the thing that makes it equal 0, which is -1. So you could ask this question two ways. Does the factor x plus 1 factor into x squared plus 3x minus 4? Or the other way you could ask it is, root, remember the rational root theorem? Does the root of -1 make this equation equal 0? Because this is what's called the root. That's the factor, that's the root. Do you get what the root is then? All right, so if -1 is a root, in your head, figure out if that actually equals 0. Does that equal 0? No. Then -1 is not a root. All right? Now, if we had tried -1 in this, you remember this thing where you drop it like it's hot? Everybody please do that. This is called the synthetic division. You learned it yesterday. And that -1 is the root. And we already figured out it's not supposed to work. So I suspect the answer is no, it's not a root, but then I have to give the remainder to prove it doesn't work. All right, did you drop this down? All right, did you multiply? Combine them or add them in this case. That one happens to be negative, so I like to say combine them. And that makes 2. Multiply them. 2 times -1 is -2. Combine them makes -6. That's weird, because if that's supposed to be 0. So this thing has a remainder. Do you get why I can prove now that -1 was not a root? All right. I'd like you to check if the same equation, x squared plus 3x minus 4, we just checked -1 to see if it was a root. Would you please check +1 to see if it's a root? So write this down. Do long division except with synthetic. And see if +1 is a root. I think it might be. Remember, there's a 1 in front, right? So it's 1, 3, -4. Draw the line. Drop it like it's hot. 1 times 1 is 1. 1 plus 3 is 4. 4 times 1 is 4. Holy cow, I was right. That's a remainder of 0. So would you please write what the actual factors are then? Because we just proved 1 was a root. Now what are the factors? Come on, lock in. Some of you haven't touched your iPad in a while. I don't want to embarrass you personally, but if you're just staring off into space, not touching your iPad, you're not doing math. All right, Libby, the 2 factors, one of them, this root tells me a factor of what? X minus 1. Good, okay, and how about the other one? X plus 4. Very good. This is the constant, and this is the x term. There you go. That is the factored answer. Do you get we just factored this into this? And in fact, I now know that 1 was a root, and there was something else that was a root. What was the other root? negative 4. Do you get this negative 4 would have also worked if I would have put it here? I'd like you to prove that. Would you please put negative 4 here and then do the 1, 3, 4. Or sorry, 1, 3, negative 4. Prove that negative 4 is also a root. Today is the day I probably say root more than any other day because the title is called Rational Root Theorem. And the roots and the factors are intricately tied together. So we're doing lots of factoring, so I'm going to be saying root a lot. All right. Drop it like it's hot. Multiply. Combine. Multiply. Ooh, look at it. I got a remainder of 0 again. And if I broke this one down, it would be x plus 4 because the factor and the root are different. And the factor for this one would have been x minus 1. Raise your hand if you had that one right. Cool. Okay, I think you get the idea of these roots here are kind of a big deal. They also make the equation equal 0. Because look, if I put negative 4 in, look, it makes the equation equal 0. Okay. Now, how do I just give you this big problem like x to the third plus 3x squared, please write this down, minus 6x minus 18. How do I figure out what roots to check? Like, if I don't know what the roots are, then how am I supposed to do synthetic? I mean, like synthetic, usually you take this number and you go 1, 3, negative 6, negative 18. That's all great. And you have a line like this. But you're supposed to have a number right there in here, and you're supposed to know like what roots. They usually give you a root. Or they give you a factor, and so you can figure out the root. But what if I don't give you any of that? Could you randomly test numbers? Yes. There's a lot of random numbers to test, so you don't want to do that. So, who's got a short-term memory? What's the first thing I started with? Nope. F con over F co. Please write that over on the side now. F sub con, that's factors of the constant, over F co, factors of the coefficient. Now there's lots of coefficients, but which one do you think is the boss coefficient? There's tons of coefficients. 1, 3, negative 6, negative 18. Oh, wait. Negative 18 isn't even a coefficient. Negative 18 is the constant. See, factors of the constant, the negative 18, over factors of the coefficient, which is the boss coefficient. The 1. That one. Because it's on the lead term. The lead term is the boss. It's like in the Army, if one guy's got 3 stars on his lapel, he's a 3-star general, would be bigger than the 2-star general. Okay, so this one's the boss. All right, so the 1 is the lead coefficient. So it's the factors of the constant, which in this case is 18. Don't worry about the negative. I'll explain later why. And the factors of the coefficient, which is really just 1. Well, that's incredibly easy because the factors of 1 is just 1. Would you agree the factors of 1 is just 1? There's only one factor of 1. It's 1. Now, the factors of 18 are a little more intense. Would you agree that 18 is a factor of 18? So 18 is one of them, comma, we got to list them all. 9. Let's go with biggest to smallest. What's next? 6. What's next? 3. What's next? What's next? There you go. Now, one more thing. When I divide them all by 1, do you get, I just have the same numbers I had in the first place? Okay, so it's really just all of those numbers. And the pain in the butt part that makes it even worse is it could be positive or it could be negative of any of those. So put a plus minus in front of the whole thing. And dividing by 1 doesn't really do anything, so I'm just going to scribble it out. So there's my possible roots. Do you get on the test? We are going to have problems where you have to pick out one of those and try it, and then pick another one out and try it, and pick another one out and try it, and pick another one out and try it. This is probably the most tedious test you ever take in math, because you don't know what number to put there, but you have a list of things you got to try until you find it. So wait, I don't want you to do this just one at a time and have to, theoretically, there's 1, 2, 3, 4, 5, 6 times 2 is 12. There's 12 numbers you have to test. So we're going to test it this way. Everybody write this out and be ready to test a number, and I'm going to tell you what number to test. We'll divide and conquer, right? In the class, we'll have some people do this number and some people do that number. All right, so row 1, you guys are row 1 right here. You guys, I want you to test 1 and negative 1. So just start with just test 1. And as soon as you find it, boom, you've got it, and we got to all stop. Okay, this row, I want you guys to test 2 and negative 2. So you're sticking a 2 in here first, you know, and trying it, seeing it worked, and then test negative 2. All right, you guys, I want you to test 3 and negative 3. Row 3, you're testing 3 and negative 3. Row 4, you guys are going to test 6 and negative 6. Row 5, you guys are going to test 9 and negative 9. And you guys are going to test 18 and negative 18. See if you get a remainder of 0. Leo, you're testing 1 or negative 1, right? What did you test first?
1.
Good. Did it work or not? Okay. Anybody else verify that 1 is not working? All right, so we don't have to worry. It's not 1. How about negative 1? Did that work? Okay. People that tested 2 and negative 2. Anybody find one that worked? Has anybody found one that worked? There's a theory that negative 3 works. Wait a minute. Yeah, it's one of our choices. All right, let's try negative 3. Everybody try negative 3, see if it works. Drop it like it's hot. Somebody else is verifying it's working? Yup. Then we factored it. But do you get that negative 3 was kind of a random number? And wasn't totally random. It was in a list of 12 choices. And you got to just keep doing it until you find it. So then, okay, yay, it worked. What would you write for your final answer? I hope you know how to write it. Don't say it, write it. That was the remainder. Did you say x plus 3? Did you realize that was the x's and that was the x squareds? So then it's x squared. And then do I have to really write plus 0x? No, not unless I'm doing some kind of like a process where you hold the place and everything. I can just write that and I'm done. That is factored. Now, the hardest questions on the test would be this, and then with a follow-up of what are the real and imaginary solutions? Everybody, try to answer that question. Real, imag. Hint, solutions are what makes the thing equal 0. Seiji, what's the real solution? All right. You do need to say x equals negative 3. I know it's picky, but math is picky. Almost never, from now on, are you going to have an answer of just 3. Or negative 3. It's going to be like x equals negative 3. Or if you want it as the x-intercept, it would be negative 3 comma 0. My negative kind of got mixed in there, so I'm going to make it really clear there. Okay, yes?
Can you write it like that, or as a point?
That's a good question. If they asked for x-intercepts, then you should say it as a point. If they ask for a solution, you can just write x equals -3. But tragically, a lot of kids are not going to remember, and they're just going to write -3. And I'm going to have to mark it wrong. I know that's really picky. But we are really, like, banging the drum about in math, when you get to this level and above, there's almost never an answer that's just 5. It's going to be like x equals 5, or 5 comma 0, or y is 5, or more than just 5 centimeters. It's got to be more than just a number. All right. And imaginary solutions. Well, I hope you knew to take this, x squared minus 6 equals 0, x squared equals 6. Oh, wait, those aren't imaginary, are they? You know why? Because when I'm square rooting this, I'm getting the square root of a positive number. Even if it's weird, it's not imaginary. So when you got this, did you remember absolute value? Did you remember that gives you 2 answers? Remember how it said imaginaries? Oh, wait, this isn't imaginary, though. But still, this is going to get 2 answers, plus and minus root 6. But you have to remember that's x equals and x equals. Now, if you'd have said x equals plus and minus root 6, I would have taken it. Imaginaries, none. To really make sure you get why it wasn't an imaginary, because there was not a negative underneath the root. Square roots of 6 are strange, but they're not imaginary. Okay, cool. I think you've got the idea. What's the main formula for today? F-con over F-co. See if you can use that then to tell me what the possible roots are of this. What are the possible roots of this? Factors of the constant over factors of the coefficient. But which coefficient? The lead coefficient. So, the factors of the constant are, the constant's just 1. And so, what are the factors of 1? It's just 1. And then, what's the factors of the coefficient? 1. And then, does anybody remember how to finish this thing? Plus and minus. And final answer is really just plus and minus 1. Those are the only things that could work. Isn't that kind of cool? Those are the only things that could factor out. That would help you factor it anyway. So, do it. What do you mean do it? Actually use those in synthetic. Oh, wait a minute. This has got that weird missing term thing. Do you remember that? If it goes from 4 to 2, then like, ooh, there was an x to the third that was like missing. So really, this should be written as x to the 4th plus or minus, doesn't really matter. 0x to the 3rds minus 3x squareds plus 0x to the 1sts minus 1. So that tells me what my synthetic should look like. 1, 0, -3, 0, and -1. Kenneth, how do I start this thing? Immortal. Very nice. 1 times 1 is 1. Add them together is 1. Multiply them is 1. Add them together is -2. Multiply them is -2. Add them together is -2. Multiply them is, oh, it doesn't look like it's working. Can I just stop? No, you got to wait and get the remainder. So this is -2, and then you put them together and you get -3. So if you wanted to say 1 didn't work, you could prove it by saying it had a remainder of -3. Did anybody try -1? Did it work? You are correct. Is it possible that something can't be factored? Yeah. We usually don't do that on the test because it's just cruel. Especially if you have to like check 6 things and then you're like, wait a minute, which one was actually wrong? Nope, they were all wrong because it didn't work. No, we're not going to do that. But if we did, this thing would be called prime because it can't be factored. It's a prime number. Just like the number 17, you can't factor it. You might be like, well, 1 times 17. The definition of a prime number is it has exactly 2 factors, 1 and itself. So 17 has 2 factors, 1 and 17. But prime numbers have 2 factors. They don't have any more. Okay, so let's go to page 2, and now you know everything. I jump right to this the way I do my formula. The factors of the constant over the factors of the coefficient. Fcon over Fco. And so then dividing by 1 doesn't really do anything. So these are the possible factors. And you'd have to check all 6 of them. And again, I'm telling you, I don't think we would ever have one where none of them work. Now, one more thing that you could do, it's kind of a cheat hack, but it's kind of fun to know. If I wanted to make sure these actually worked as a factor, like I think 2 works. My theory is I did long division with synthetic, and I think 2 works. Do you get if I stick 2 in? What's it supposed to make the equation equal? 0. Do you see how you could just do that? You could just stick in a 2 and see if it actually equals 0 or not. It's kind of a pain, but you could do it. 2 to the third is 8. 2 squared is 4 times 4 is 16. That's negative 16. And that's 2, and that's negative 4. Does that actually add up to 0? Nope. So, and I can tell you 2 is not a root. I sometimes question why we wouldn't do it that way instead of long division. But one thing you can't get out of this is what the remainder is. All right, so let's move on to this page. All we have to do is list the possible roots. So figure out Fcon over Fco, simplify it down, and get a list. You don't have to even check them. Just get a list for me. For number 1, let's not do number 2. We'll just do number 1 first. Do you have to write Fcon? No. You can just know it's factors of the constant. So that's going to be 1 and 2 and 3 goes into 12 and 4 and 6 and 12. And it doesn't matter if you start with the biggest or the smallest. It doesn't matter. That's a list of the factors of 12. That's the factors of the con over Fco, which is factors of the coefficient, which is just a 1, which is pretty sweet. It's just a 1. And don't forget the plus minus. And then this actually will cancel out because dividing by 1 doesn't really do anything. So there's 1, 2, 3, 4, 5, 6 times 2 is 12 things that are possible roots. And you'd have to do synthetic on each one of them until you finally find it, because when you do find it, it'll factor it. Because see, like if I use that cheat hack I was talking about and I figure out that, hey, when I stick in 2, it makes the whole thing equal 0. That's great, but then you haven't factored it. You know what I mean? You still have to factor it. So if you're doing the synthetic and you check 2, you'll be done and it'll already be factored. See? So that's why we wouldn't just say stick in 2, see if it equals 0. Because, yeah, you might find out 2 works, but you haven't factored it then. You still have to go back and factor it. All right, on this one, would you please figure out the Fcon over the Fco? Problem 3. Say G. Leave me a list of the Fcon.
10, 1, 5, 2.
I like them in order, but it's not illegal. Okay. I think he's got all of them. Over what's the factors of the co? Seiji? There's one more factor. 1. Okay. Okay, good. And then what do I need in front of that whole thing? Plus and minus. And then, what do I do now? You cannot leave that as your answer because you've left me with a math problem. Everybody write out a list. You can put a plus minus at the beginning of it of all of the things that are possible roots. Remember, that means divided by. Yes, there's fractions. I doubt that on the test we would be so mean as to make you do synthetic division with a fraction. But so fractions are for sure in your list of possible roots. Did you have 10/3 in your list? Did you have 1/3 in your list? Did you have 5/3 in your list? Did you have 2/3 in your list? Did you remember that you had to divide them all by 1 also, which is 10 divided by 1, which is regular 10, regular 1, regular 5, and regular 2. That is 16 possible roots because of the plus and minus. If I had to actually test all of those, it would really suck. But I would start with the easy ones, like 1, or 2, or -1, or -2. All right, let's move on. They're saying, here is a problem. We've already figured out the possible roots. Let's actually test all of them. So I want you to see what it's like to test it yourself. They've already got it all set up. Just take a second and do these 6 synthetics. And all you're really trying to do is figure out which one has a remainder of 0 and then write out the factors. Remember, once you found it, you have to write out what did it factor to them. Yes. Sure, as long as the hub pass says yes, I'll bring it up and you can leave it on my desk as you walk past. Just taking attendance quick. And everybody is here, yay. Thank you. Who found it? Which one was it, Leo? 4? All right, I'll check you. 1 goes here, 1 times 4 is 4, add them, 0. Multiply them, 0, add them, 1. 1 times 4 is 4, 0 remainder, awesome. Then don't forget that you gotta actually write the factors. This 4 gives me an x minus 4. And there's a 1 here. 0 x's, I don't have to even write a 0x. It's a 0. 0 x's, and this is x squared, and then this is plus, and there we go. Raise your hand if you had that one right. Cool. See how that isn't that bad? Could you do the last part, which would be, how many real solutions do you have? How many? Just how many? Only one real solution. Because this part, you'd have to use an imaginary number to work. So, how many imaginary solutions? 2. Remember that imaginaries always come in packages as 2. Because if like -1i works here, then +1i will also work there. And yeah, there's 2 answers for this. And there's 1 answer for that. So there's 1 real one and 2 imaginaries. All right, to this page. Now, on this, they're just telling you stuff we already know, which is like how to write them as factors. So we can skip the pink page. Go to the yellow page, and now notice it's just a big, long polynomial, and they're asking you to figure out what numbers you could test, and then test them until you find it. So this is just plain factor this by using FCON over FCO. Go ahead, give it a shot. Can you factor the hardest, nastiest thing you have ever factored in your life without my help? Okay, I think there's 8 things possible. Has anybody found one that works? All right, quite a few people have. How about this? Just tell people which ones don't work. Nominate one that you know doesn't work. 1 doesn't work. What else doesn't work? 6 doesn't work. -6 doesn't work. All right. Now, could there be more than one that works? Yes, that just means that if you got this thing all factored, and let's say it came out to this. Do you get there would be 3 things that work? So it's not like you need to find the only one that works. There might be more than one that works. All right. I'm ready. Somebody tell me one that you know works. 3? Awesome. 1, -1, -5, -1, -6. Drop it like it's hot. Multiply, add, multiply, add, multiply, add, multiply. Cool, it made a 0. That's my remainder. And now this comes down to be x minus 3. And this whole thing, it's got a 2 at the end, a regular x, 2x squareds, and an x to the 3rd. Little pluses in between. And then how could somebody have found another thing that worked? Well, like 3 worked, I know. What else worked? Yes? Yes, if we factor this the rest of the way, it'll work. So wait, somebody tell me another number you tested and worked. Negative what? -2? Then -2 will work on this. See, -2 will factor out of that, so you'll end up with an x plus 2 in it. But just know that if you found another thing that works like -2, that's your job then, is to go factor this guy by using the -2 root that you also know works. Sweet. There's my remainder. And that's an x plus 2. And that's an x squared plus 1. Not even going to try to factor that. I'd have to have imaginaries. And I'm going to bring this down. And that is factored all the way. Except if you want to be extra smart. Now, I like to do this in an honors class because some kids really think this is cool. And it also kind of helps get the answers. Because I'm going to ask you at the end for what are the real roots, what are the imaginary roots. Then, behold, this actually factors. I know, seems crazy. So I'm going to go off to the side and just go, if x squared minus 4 would factor, would you agree that would be x plus 2 and x minus 2, right? Then x plus 4 would have also factored, but you guys know it's going to be imaginary because to make this whole thing equal 0, you'd have to use imaginary numbers, right? Think about that for a second. X plus 2i and x minus 2i. How does that factor? Because look, x times x makes x squared. The outside and the inside cancel. And the really cool part is that that times that makes that. See how you can actually factor that? So, the extra smart kids on the test will show me that because they'll go, actually, you can factor it further, Mr. Server. Process that for a second. What just happened there? Okay. And these answers have I in them, so it's going to be pretty obvious that they're imaginary. And I know what the imaginary answers are now. It's plus and minus I. All right. To see if you really caught that, imagine you just got to the end of a really hard problem and it had this. Factor it further. You've never factored using imaginaries, but now you can. Now, if you can do that, raise your hand. Awesome. Now, do you get it? It will be just as good if you want to say, I want to get my answer this way, Mr. Server. This just makes more sense to me. I would rather do this. And then I'd rather do this. And then I'd rather do this. And I would say, why would you rather do all of that? Like, I'd rather just factor this, and then I know my answers are 2i and negative 2i. See how that's a lot faster? But if you want to solve them the old-fashioned way, you still get plus and minus 2i. All right, final test. Factor this. Factor it all the way. Mr. Friday, what'd you start with?
Well, factoring out of 4.
Nice. Then you had x squared plus 4. Then what'd you do?
Then I factored it and I got x plus 2i and x minus 2i.
You got it. It's really not that hard, is it? And now, that is not required factoring because it's unusual. It's not real. But I think it's helpful factoring because then if they ask me what the roots are, I'll be like, oh, it's 2i and negative 2i. And it's faster than having to set this equal to 0 and solve it and show all of that work. Okay. You are ready. If I just gave you this, don't even do it, what would you start by doing? I heard an F. F con over F co, yep. And then you'd realize, oh, there's these 5 possible, no, there'll never be 5. There's good, well, I'm just trying to say, it'll be plus and minus a set of numbers. So there's always going to be some even number of numbers. So it's probably like 6 things I got to check. And then you check them all with factoring by long division? No, you're probably going to use synthetic because it's way faster. So you check them all with synthetic and then you finally get it factored. And then what are you going to check for? Can you factor it again? And then what are you going to check for? Make sure that you got even your imaginary stuff factored. So if it's like this, even that you could factor. It'd be weird, but you could do it. X and plus and minus, and it must have an I because it's imaginary. Can anybody tell me what to do? What would go here and here? Come on, you can do this. Ooh, what? Say it louder. I root 18, yes. You'd usually take the square root of this, right? So still take the square root of it. Square root of 18. And then I've got my roots. It's I root 18 and negative I root 18. Yes?
Did you have to simplify that?
Ooh, you got me. You really should.
Yeah.
The root 18 is root 9 and root 3, so that's 3 root 3. Good point. Oh, you're right. That's a 2. That's a 2. Nice work. You're on fire today. 3 root 2. Okay. So, you got a homework assignment. Find it. Let's give you the rest of the hour to work on it. I'm going to cut it down to be a reasonable size. Schoology quiz. Okay, let me look at it and make sure it's not too beastly. Settings. 2 times by average score. Yes with correct answers. So you'll see the correct answers after the first try. There's only 7 questions. That is doable. Although there's lots of parts on them. I will cut off problem 7. It is now deleted. You'll have 1 less problem to do. And that saves you 3 parts to the answer. All right. So, numero uno. Unfortunately, some unlucky person has to read it to me. If you want to volunteer, you'd save somebody else the pain. Thank you, sir.
For the polynomial equation below, what are the possible rational roots?
Got it.
Y equals x to the 5th minus 3x to the 4th plus x to the 3rd plus 2x squared plus 3.
Thank you. Now, the factors of the con over the factors of the co. Factors of the constant are 3 and 1. Factors of the coefficient, just 1, plus and minus in front of that. So there's 4 things I could check. I think, right? All right. So let's just check 1 first. And I got to get these numbers. 1 and negative 3 and 1 and 2 and 3. Draw the line, drop it like it's hot. Didn't work. Remainder's 2.
It's just asking for the roots, though.
Oh, all you have to do is roots?
Yeah.
Okay. Then I would just erase that. And then how the heck am I going to type in a plus or minus sign? You can't. So you just list all of them, and there's 4 answers. 3, negative 3. 1, negative 1. Unless there's a plus minus in the answer blank. Is there? Okay. Is there 4 answer blanks? Excellent. Yes.
That's great.
This question is
Number 1. Still doing number 1. All right.
Oh, and then
That's all I got
question
for you for. Oh, question 2.
two-
Yes.
Question 2 is finding the root.
Oh, then you actually have to do it on the roots. Okay, so at least you guys know that 1 didn't work. Okay, that's all I got for you for today.